Certainly. Below is the pure English narration version of the script. No headings like intro or closing. Just a clean, natural flow of information, ideal for a compelling and informative YouTube video. On May 31st, 2025, the sun unleashed a powerful solar flare that caught the attention of scientists and the public alike. This sudden burst of solar energy not only illuminated the sun's dynamic nature, but also reminded us of the invisible forces that can impact our planet in profound ways. A solar flare is an intense eruption of electromagnetic radiation from the sun's atmosphere, typically occurring in areas of concentrated magnetic activity known as sunspots. These flares happen when magnetic energy stored in the sun's atmosphere is suddenly released. The explosion sends out bursts of X-rays, ultraviolet radiation, and energetic particles, which can reach Earth in a matter of minutes. Solar flares are classified into 5 categories: A, B, C, M, and X, with X being the most intense. The May 31st event was categorized as an M8.1 class flare, placing it near the threshold of an X-class eruption. It originated from active region NOAA 4100, a sunspot complex that had already shown signs of magnetic instability in the days leading up to the event. The flare was accompanied by a coronal mass ejection, CME, a massive cloud of solar plasma and magnetic field ejected from the sun's corona. Traveling at approximately 1,238 kilometers per second, the CME was Earth-directed, a rare and potentially hazardous trajectory. NASA's Solar Dynamics Observatory and ESA's SOHO mission captured the eruption in real time, showing an immense wave of energy expanding outwards into space. Within minutes, the solar flare ionized the upper layers of Earth's atmosphere, disrupting high-frequency HF radio communications across parts of South America and the Pacific. Shortly afterward, as the CME reached Earth, a geomagnetic storm developed. According to NOAA's Space Weather Prediction Center, the storm reached G4 level intensity, classified as severe on a 5-point scale. This geomagnetic disturbance led to several noticeable effects. There were temporary navigation errors in GPS systems, slight anomalies in airline communication, and increased atmospheric drag on satellites in low Earth orbit. Some power grid operators initiated precautionary protocols to avoid transformer damage, although no widespread outages were reported. Meanwhile, a more visually stunning consequence unfolded in the night skies. Auroras, usually confined to polar regions, were visible much farther south, dazzling viewers in parts of Canada, northern Europe, and even in unusual locations like northern Turkey. Social media was quickly filled with breathtaking photos of colorful lights dancing across the sky. Scientists had been closely monitoring active Region 4100 for days before the flare occurred. Forecasts issued by NOAA and Space Weather had already indicated a high probability of strong M and possible X-class flares. Though the exact timing of solar flares cannot be predicted, monitoring sunspot behavior and magnetic configurations offers early warning of heightened solar activity. This event also raised important questions about our technological resilience. As we become more dependent on satellites, global communications, aviation, and power systems, we also become more vulnerable to space weather. NOAA and NASA have both stressed the need for improved space weather forecasting and infrastructure shielding as we head deeper into solar cycle 25. The current 11-year cycle of solar activity, which is expected to peak in 2025-2026. The May 31st flare is just one of many to come. As the sun continues its climb toward solar maximum, we can expect more frequent and possibly more intense flares and CMEs. While Earth's atmosphere protects us from most direct harm, the growing complexity of our tech-dependent society means that even minor disruptions can have major ripple effects. This event serves as a powerful reminder of our connection to the cosmos. Despite the vast distance, the sun's activity directly influences life and technology on Earth. Understanding it isn't just an academic pursuit. It's a matter of global preparedness.